This larval assay is meant to test wild population of mosquitoes for reduced susceptibility to active ingredients that are commonly used as larvicides. At the end of the video, we will provide resources for validating your own assays if you test different active ingredients and mosquito species. Each larval assay requires about 150 mosquito larvae. It is important that these are gathered from multiple egg rafts or egg sheets to ensure that you are not testing offspring from only one female. You will get a more realistic idea of the susceptibility of your local mosquito population if you sample from many females, ideally 20 or more. Biological larvicides such as BTI and L. sphericus need to be ingested by the mosquito larvae to work. Since late 4th instar larvae stop eating prior to pupation, it's important to use late 3rd instar or early 4th instar larvae to ensure they will consume the pesticide. Start by labeling your cups, with one clearly labeled as a control cup. Using a pipette, place 15 larvae into a graduated cylinder. Then bring the volume up to 74 milliliters using deionized water. Quickly pour the larvae and water into wax cups, making sure that all larvae make it out of the graduated cylinder. If you pour too slowly, some larvae will get stuck in the cylinder. If some larvae do get stuck, pipette some of the water from the wax cup back into the cylinder and pour again. The goal is to have precisely 74 milliliters of water in the cup with the larvae. Once all larvae are in the cups, add roughly 50 milligrams of fish food to each cup. This will be enough to keep the larvae alive, but not enough to create a layer of grime on the top of the water that could suffocate the larvae. It's important to fully set up the entire assay prior to treating the cups with the pesticide. This way, the treatment times will be close together, saving you time when checking the results the following day. Finally, dilute your pesticide to the correct concentration. If you are using the NEVBD larval testing kits, the concentration will be the LC99 for the species you are testing. Now that the assay is set up, record the time and pipette 1 milliliter of diluted pesticide into each cup, bringing the total volume up to 75 milliliters. Don't add any pesticide to the control cup. Instead, add 1 milliliter of water to the control cup to bring the volume up to 75 milliliters. Store the cups in a climate-controlled space appropriate for the species you are testing. Check for mortality at 24 hours after the pesticide was added. The methoprene assay differs from the previous assay in a couple of ways. Methoprene is a synthetic hormone that regulates mosquito development. After being exposed to methoprene, mosquitoes will often die as pupae and fail to fully emerge as an adult mosquito. We recommend using early 4th instar larvae for this assay. Methoprene is mixed in acetone, so instead of adding 1 milliliter of deionized water to the control cup, you will add 1 milliliter of acetone to the control cup to bring it to the correct 75 milliliter volume. We recommend using 2 control cups for the methoprene assays for clearer results. Once the assay has been performed, the wax cups need to be placed into an adult emergence container. We use a 16-ounce soup cup with tulle on top for this purpose. The assay is run until all mosquitoes either eclose into adults or die. For susceptible mosquitoes, this typically takes 4 days. For resistant mosquitoes, the assay could run up to 7 days. It's important to check the mortality daily since eclosed adults can die over the course of 7 days. A fully susceptible population will have 100% mortality at the end of the assay. Your control cup should have no mortality. If your control cup has greater than 20% mortality, the assay must be discarded. If you see some mortality in your control cup, but less than 20%, you can apply this equation. If you have less than 90% mortality in the treated cups, your sample may have reduced susceptibility to your ingredient. To test for more severe resistance, use a 5-fold concentration in a 10-fold concentration of pesticide. The amount of larvicide in solution you will use depends highly on the material of the cup. For this reason, any different materials used in the assay will need to be validated by finding the lethal concentration for each combination of larvicide, cup, and species.